Hi, this is a overview video of the Lancaster game engine, which is a game engine that can build different kinds of games, but primarily suited towards the idea of 2D games, much like what you're seeing being played right now, which is the demo game. It also supports multiplayer games. So what we're seeing here on the screen right now is 3 different players. So this is the player named Java, and here we have a player named Scout. Actually need to help Scout get across. Whoops, let me get this back. So we're seeing 3 different players play, and they're all connecting over the network. Now you're seeing them all on one computer right now, but they can be played across many different computers. Whoops. I'm not doing a very good job of playing the demo and talking at the same time. Let me just finish this game and then we can actually talk about what Lancaster can do. Get everyone over there and you can play this game yourself. So let's just flip to an agenda here. What Lancaster actually is and what you just saw was a server and 3 different players connecting to that server and playing a game together. So it's an online game engine that allows you to develop what we call 2D orthogonal games. And the 2D orthogonal part is just kind of the general look of what you just saw graphically. And the network part is the magic that does the multiplayer. So when looking at Lancaster, it's something that is a game engine because you can extend it. You can actually make your own games with it. And the start for that is just to get the base code for Lancaster. And you can do that right here at this link. And this link will take you to the Lancaster page on GitHub. So when you arrive there, you will see a listing of the code. You'll also see a write-up with and about with several of the features of Lancaster. Now, what I encourage you to do, step 1, is to actually just go download the code. If you don't want to clone the repository using Git, you can just download the zip file. So just from the green button says code, download zip, and you can download it, and then you'll be able to run it. There are a few caveats to that, and there is a setup and run section. So if you read within setup and run, it tells you what you need to actually run Lancaster. And effectively, you need Python 3. It's been tested with Python 3.10, which is a recent version, but anything Python 3.6 or above should work without any problems. If you're not familiar with Python as a programming language, python.org is where you can download it from. And there's also documentation there. There's documentation that will get you started if you haven't done Python before. But if you just want to run the Lancaster demo, you don't need to know much. Just download and install Python. You'll also have to install some Python modules. So just follow the directions there. And that will let you run the demo. Now, Lancaster as a tool, when you download it, what you're going to see is several things. And let me actually pop into a directory here. So when you download Lancaster, you're going to see a set of files that look like this. And there's a couple important files that I'll talk about right now. The first one is the run-demo.bat, and that's actually going to run what you just saw. So it'll run the 3 clients with the demo game and the server with the demo game. And I'll do that manually for you in a minute so you can see what that looks like. And you'll see several other directories. The most important one here is the source directory. So in the source directory, you will actually see Python scripts, one called start client and one called start server. Those are the scripts that actually start the client and server respectively. You can ignore the start connector for now. One of the things that Lancaster is very good at is running on a local area network. So for instance, in a classroom or in one home. And that's right in the name. I mean, the LAN in Lancaster stands for local area network. The connector that you see here, it will actually allow you to run over the internet. So between houses and things like that, but that's a topic for another video. So the other things you'll see in here are the engine directory. So this is all the base code for Lancaster that you can build on, but it's all of the built-in code that you would want for the game engine. You'll also see a demo folder and an engine test folder. So these are games. So any other folder in this directory in Lancaster source is going to be a game, and you can have several games in there at once. So if I go into the demo folder, for instance, what I'm going to see is some more Python code. I'll see some tile sets, maps, images, fonts, and docs. The code here, you'll see that some of the file names here are the same file names you'll see in the engine folder. Those are actually extension files, so they are subclasses of the same files in the engine folder to add functionality specific to this game. So if we talk a little bit about that, it's something where you can build your game on top of Lancaster. There's a lot of functionality to replace functionality or build on top of. But maybe what we'll do here is just talk about how to run the demo. And I'm just going to do it on the command line just so that you can see that. And then we can talk about the architecture behind it. So let me just get up. I'm on Windows, so I have 4 command prompts. And I'm just going to clear each one of these out. What I'm going to do with each of these is run a different part of the game. Now, these could each be on a different computer again. I'm going to do them all on one computer. So let me just do this. So to start with, I'm going to start the server. Now, if you look in the file I already talked about, so if we look at the file called rundemo.bat, you'll see a whole bunch of stuff that has to do with how Windows bat files work. You don't really need to worry about, but everything after the PY. PY stands for Python. The -3 just ensures that version 3 of Python is running. And you'll see we run start server once and start client 3 different times with 3 different player names as a command line option. So let me just do that, but I'm just going to do it for you right here. So the first command I'm going to run is py. And I should say I'm already in the Lancaster directory. So I'm in the directory that has the run demo script, and it has the directory for the source. So I'm going to run py source/startserver.py. When I do that, not much exciting happens. It just says, hey, there's some, I'm listening on some ports. And that's because the server doesn't do anything until a client attaches. So when we run a client, and so I'm going to run a client and I'm going to say player name Java. And let me just stop here for a second. I'm just going to back up. I'm just going to ask for the help. So I'm just going to run start client with -h. And that'll tell you all the things that you could put as an option to run this on the command line. But all I want today is just to run -player Java. And that's going to start up. And hey, we see a window. So we see some things. We see some chickens moving around. I see that my name's Java, and it's this little character icon here. It's got the name Java under it. And I see a banner that says all players must gather in the stone circle to win, waiting for 2 more players to join. All right, well, let's get 2 more players to join. So here I'm just going to run another client with the river as the player name. And there we go. We see River down there at the bottom right. Maybe we'll throw that one over to the right because he's on the right. And we'll run the last window here. And we'll call this one Scout. Okay. So what we have now, if I get all 3 of these up. There we go. They're stacked on top of each other. Okay. So now we have all 3 clients have joined the game. And again, normally this would be on 3 different computers with 3 different people playing. But each window now allows that player to move around. And in each of the other windows, the other players can see what's happening. And players can switch maps by go different places and so on and so forth. So I just want to talk about what just happened visually there for a second. And just come back to the idea of, we've run this process, but what's really happened? And to do that, we want to talk a little bit about the architecture of Lancaster. And I really want to start with this idea of the data of Lancaster. And there's 2 kinds of data that feed into Lancaster, and then there's a bunch of code. Okay, so a bunch of Python code, but let's start with the data. There's 2 kinds of data, that's maps and tile sets. So we have a tool called Tiled. And let me just open, so this is the tiled program. Let me just open the start map. So this is what this map looks like inside the tool we use to create these maps. And let's talk about what this tool is. So if we go to its website, so the website is mapeditor.org, you'll see the tile tool that you can download. When you download it, if you want to develop maps for Lancaster, I recommend you use version 1.7.2 of Tiled. And that's just because that's the version that Lancaster has been tested against. So that's where you get it from. It's from, again, mapeditor.org. And this is what it looks like. And there's two things we see here. In the center of the screen here, we see the map for the start map. And up at the top right, you'll see all the different layers of this map. And probably the most important layer is the sprites layer. And I'm just going to turn the visibility of that on and off, just so you can see that that's a layer of itself and it has some things on it. There'll be another video with more details about what that is. And then on the right over here, you'll see the tile sets we have available. So if we go, for instance, look at the soldier tile set, you saw this little soldier walking around. Well, these are all the different images that make up the soldier walking around. So that's called a tile set. And then those tile sets are used to draw maps. And that's the basic setup of Lancaster. Now, just to go a little deeper, if we go back to our file structure and we go look in the Lancaster source demo directory, so this is the demo game directory, we can see in the images directory that there is a soldier.png. So tile sets are made of images. So that's, it's nothing fancy, it's just there's a image on which you base a tile set. And then the tiled program, it actually adds a bunch of data to that. And if we look in the tile sets directory, so we're in Lancaster source demo, tile sets, we will see a soldier.json file. Something I didn't say before is tiled outputs data as JSON, or that's how we want to make it work for Lancaster. Tiled has a lot of features that Lancaster does not support, but the core things it supports are documented. I'll show that a little later on GitHub. So that's what a tile set is. And then a map, very similar. If we go back here, Lancaster source demo, and we look in the maps folder and we look in the start folder, we see some code for that map. I won't go into that right now. And we'll also see start.json. So again, that map that you saw visually, it's stored as a JSON file. So again, a lot of data here, but the Lancaster game engine takes care of loading this data for you. So that's the first thing the engine does. It allows you to use tile to generate that data and allows you to load that data. So the next thing it does is it starts up these processes. And you've seen this now when we ran the demo, that it starts, in the case of the demo, 4 processes. So let's just talk about what happened there for a second. So we did a couple things. We started a server process first. And then we started 3 clients. I'm just going to write down C for clients. Now, the server and the clients, they all had all of the data. So I'm just going to write data. Okay. So they all had their own copy of the data. So they're all running on different computers. They've got that data. And that data, again, that's the tile sets, it's the images and the JSON files for the tile sets, and it's the map or it's the JSON files for the map. It might also be fonts. It's the Python code. That's all the things that make up the game. So everybody needs a copy of that. And then when each one of these runs, a client simply says to the server over the network, it says, hey, may I join the game? So may I join? And the server will respond with yes or no. Now, when you generate your maps, that specifies how many players can join the games, because you'll put icons on the map, or I guess tile objects on the map that are of type player. So if you have 3 players on the map, or actually anywhere throughout your game, then 3 players can join. Once you have more than that, then no more players can join. So that'll happen for each client. Once each client has joined, the game can actually start. So you'll have this 2-way communication that exists between each of the clients and the server. Once they've each joined, they've been allowed to join. And we'll come back to this picture in a second. But let's talk about where to go from there. So that's the processes. Now, just a little discussion about what the difference between these processes are. Like, why do we have a server and a client? Why don't we just have a bunch of clients or players that just talk to each other? Why do we need the server? So to make things work logically, we need to have one place where all the decisions are being made together at the same time in a logical, orderly fashion. And that's the server's job. So for that reason, the server runs the game logic. So game logic, what do I mean by that? For instance, if one thing in the game contacts another thing in the game and it causes the other thing to move, the server does that. If if uh, if one user throws a lever that causes a bridge chain, that's done on the server, and the clients are simply sent that as an update. The other thing the server does is it takes care of time. So if we think about our game, it has to move forward in steps. So as a player, I want to see an animation of what's happening. I want to see my player walk along and move. And it's, the server has to do that step by step by step 30 or 60 times a second. So it takes care of stepping forward in time in small increments. And the other thing are things like game mechanics, and I won't get into that too much today, but when you write code to add features to the game, you're adding mechanics, and that's all done on the server. So what does the client do? The client really only has two very simple jobs. It takes input from the human player, and it sends something to the server to say that this input has occurred, and it receives updates from the server to show to the player. And it does all this over the network. So that's the division of labor. So if you wanted to do something that was a really pretty animation, you'd probably be doing client work. If you want to do something that has to do with bouncing a ray of light around, well, it starts on the server because the server has to understand the logic of that and compute it. But then you might have to do some work on the client to make sure it gets displayed properly. So sometimes it'll be broken down between the two. Sometimes it'll purely be game logic. If there's a wall that a user can't pass, the client may never need to see all the details that it simply happens on the server. All the client knows is that the icon doesn't move or the tile object doesn't move. So I'm just going to go through that again quickly back on our diagram and just talk about this from a networking perspective. So once we've all joined the game and we're playing, the clients really are sending input from the user. So that is mouse events, keyboard events, things like that. And what the server is sending back is a constant stream of steps. So this is step 1, this is step 2, this is step 3. And again, a step is just a point in time. So it's every 1/30th of a second or 1/60th of a second. The server is sending back these updates. And they're not really screen updates. Don't think of them being pixels, right? Because the client is in charge of drawing the pixels. What is sent back from the server to the client is the data it needs to draw. So that's what's kind of happening from a client-server perspective. And it's fairly straightforward, but it's happening very quickly. So that's where you kind of get the complexity of it. All right. So what I want to do is talk about how you might make your own game. So to start with, I just want to go back to the GitHub page for a moment that we already looked at. So we looked a little bit at the, you've probably seen the About page, that's where we landed, the Setup and Run page. I alluded to the fact you can run this on separate computers, and there's a section here, how to run it on separate computers, and that's very fun to do. You have to know your IP address and those sorts of things, but it's just a few command line options, so it's not hard. I recommend you get it all running on one computer first, and then you work with a friend or 2 or 3 and run it on multiple computers. The other information you have here is how to create a game. Now, this is not complete, this page. It is simply the most basic things that you would need to know. The first one is file organization. I touched on some of this, but how the files are laid out for a game. So you might want to look at that. You also see here the link to the map editor and some very specific details about what Lancaster supports. So for instance, Tiled supports rotating objects where Lancaster doesn't. So if you rotate an object in Tiled and save it, that's great. But Lancaster is going to ignore that. So this talks about exactly what format the maps need to be in, how you have to save them. Tiled has a lot of options to do other things, other file formats, but this tells you exactly what Lancaster can support. And then also the idea of extending it. So I haven't touched on code at all in this video. But the basic engine doesn't do much for you. It gives you a whole bunch of tools in your toolbox, but it doesn't put them together into a game. So there's two things you can do by extending Lancaster with code. The first one is to add new game mechanics or new display types or things like this. The second thing you can do is build an actual game logic. Like, what does the game do that you want? I mean, the engine doesn't do that for you. It doesn't know what the game is that you're building. So you might have to do some of that. So if the game engine doesn't do the things you want it to do as far as game mechanics, like it can't throw an arrow or throw a fireball or cause a cliff to collapse, then you would have to extend that with a new game mechanic. But as far as the story of the game, that sort of thing is done either partially through the maps that you create and the graphics and the feel, but also through extending the code to add that kind of game logic. So you can extend both the games, and you can also have code for each individual map. The demo has 3 maps. So I'll leave it to you to have a look at how that's done for the demo. And there'll be a video exploring that a little more as well. Okay. So I think that's about a wrap up. I will say there are more tutorials like this one. Again, back on the GitHub page, there's a tutorial link, and you can have a look at that for more videos. So I hope you enjoyed that very quick overview, and hopefully you'll have a look at some of the other videos. Thanks so much.